Alright, welcome back. In this video we are going to look specifically at the domain and range of functions. Domain and range is a very important concept. It helps to tell you where your function is true in terms of the problem you have or what issues or errors you may come across. In other words, where you might have a problem. Now, a couple things we have to remember when we talk about domain, we're talking about the set of all x values. And when we talk about the range, we're talking about a set of y values. Now, we have three different ways that we can see domain and range problems. So, the first is if you're given ordered pairs. Ordered pairs is fairly simple. It just simply means you're going to create a set where you're going to list out all of your x pairs, and then you're going to list out all of your y pairs. And that would be your domain and range in terms of ordered pairs. A picture is where we're talking actually, more about a graph. In terms of a graph, your domain is going to be your horizontal axis or your x-axis. The biggest thing that you have to be careful of, or that you need to keep in mind when working with domain and range, is that you always want to make sure that you are moving from left to right. What that means is you always want to start at the negative infinity side, and you're going to move through to where you finish at the positive infinity side. Okay? And that order is really, really important. Well, it's the same with your range. You need to make sure that you are moving top to bottom. Okay, again, starting from your negative infinity, which is the bottom, going up through to your positive infinity, which is the top. Now, the last way is if you're given functions. So sometimes you are asked to find the domain and range of your function, and other times you're asked for what's called an implied domain. When you're looking for your domains, there's a couple things or hints that I can give you. First, we have two types of equations that cause problems. The first type is rational, i.e. fractions. Because these are fractions, the rule that you have to follow here is that you cannot have a 0 in the denominator. Okay, that is like the number one fraction rule that we have, is you cannot have a 0 in the denominator. Therefore, it has a very special domain, where your domain is going to go from negative infinity to your place of problem, i.e. the value that gives you a 0 in the bottom. You're then going to union it. That's what this U means. Okay, so here, this U means union, which in turn essentially means attached together or included together. And then we're going to pick up at that exact same spot and travel on to your positive infinity. Okay? So to note here is that hashtag is going to represent whatever that domain value is you found, so whatever the problem value is that you have. Now, the other type is a radical equation. Now, a radical equation, the biggest rule we have here is you cannot have a negative under an even root. Therefore, we also have a different way that we write the domain. Your domain is going to be all real numbers where you are greater than or equal to 0 underneath your radical. Okay? So, what does this mean? Well, this means that we are not dealing with the imaginary plane or the complex ideas anymore. We are back to, or just simply looking at, real numbers and the real plane. Okay, so the imaginary numbers does not exist, meaning you cannot have a domain that has an I. Okay. So what we're going to look at is we are going to look at a bunch of different examples. Okay. Now, one thing we need to note is that all domains are written using interval notation. So we're going to look at that here, showing you interval notation. First, however, I want to go ahead and find the domain and the range given a following set. Now notice, this is a set of coordinate points. So the first thing I need to do is I need to identify that I'm going to start with my domain, so D for domain, and I need to open a brace. This is going to start my set. And the only thing that I care about are the x values. So knowing that, my domain here is going to be the set where I only use the x values. 3, 5, and 7. So if you look here at my coordinate points, remember all coordinate points are written in the form x, comma, y. So you just simply identify the coordinate points that are your x values out of there. Now the other piece that I have is I need to write my range. Again, I would open up a brace, and in this case we are looking specifically at the y values. Now the biggest thing you need to remember here is that we don't do duplicates. So if you look at my y values, notice they're all the same. They're all a 1. So we just have to write it the once. Okay. So this is what we call set notation, or sets of values. Okay, that is what we're doing here. Now, interval notation is going to come into is going to occur during this next example. So here we want to find the implied domain of g of x, which equals x minus 4 over x plus 3, and then we want to evaluate the following. So the first thing we have to do is we have to find the implied domain. This is a rational. So for here, my domain is going to be where the denominator cannot be 0. My denominator is x plus 3, so here I've got that x plus 3 cannot be 0, so x cannot be negative 3. So when we're talking about a domain, interval notation says I have to start from the negative infinity, travel up to my problem spot, which is at negative 3, and then union that from my trouble spot through to the positive infinity. So this is called interval notation. Now there is one other form of notation that you could use, but usually interval notation is the preferred or what is expected. But as a side note here, you could use what's called set notation. So set notation would say that the domain is going to be the following set, x such that x cannot be negative 3, and close it. Now, when we're working with set notation, one of the things you have to remember is that this vertical bar here is the word or the meaning such that, and then it's basically the following occurs. So we're identifying the variable such that the definition occurs. Okay, so that's kind of the way it works. So this x over here is going to be where you identify the variable, and then this part over here is going to be your definition or rule that you have to follow. Okay, that's kind of the way your set notation works. So if you look at it, there's a lot that kind of is going into it or that you would have to remember, which is why we generally prefer to use interval notation. So this would be my domain here. So if we're looking at everything we need to do, this would be the first part. So now we need to do the second part, which says we need to find or evaluate g of 2. So that says anywhere you have an x, you're going to input the 2. So 2 minus 4 all over 2 plus 3. And when we do that, 2 minus 4 is going to give you a negative 2. 2 plus 3 is 5. And thus, we're done. Now the other one says we need to evaluate g of negative 3. Now, this, however, we have an issue. Here, this does not exist. DNE, okay, or does not exist. If you're going to say does not exist, generally you need to have a reason why. Here, your reason why would be g of negative 3 falls outside the domain of the function. Now, if we want to look at it mathematically, look at it mathematically. G of negative 3 would be the following. Negative 3 minus 4 over negative 3 plus 3. Mathematically, we end up getting negative 7 over 0. Here we have a 0 in the bottom, which our rule says we cannot let this occur, and that is by fraction rules. Therefore, those are our two answers. Okay? Alright, let's take a look at another one. Here, I want to find the implied domain of the following. So here we have to remember radical. Your radical rules states that you cannot be imaginary. So essentially what that means is it means the stuff underneath the radical cannot or has to be greater than or equal to 0. So here that's what we would do to solve my domain. Okay, says that you're under the radical is greater than or equal to 0. So that's what we have to solve. So under the radical here is going to be x minus 8 is greater than or equal to 0. Solve for x, we get that x has to be greater than or equal to 8. So we have to write our interval notation. So the domain here is going to be that we're going to start at 8. So we open a bracket. Bracket means included or equals to. We're going to start at 8 and we're going to travel all the way up to positive infinity and put a parenthesis. So here what we have to keep in mind is we have to keep in mind that your interval always is labeled from the smallest or most negative through to the largest or most positive. And that's how we create our intervals. We go from the tiniest or the most negative all the way up through the largest or your most positive. Okay? So in this problem, this is what we were looking for, was your domain. Alright, let's look at another one. So here we need to state the domain of the following expression. So again, this is a rational. So again, we have to remember that your denominator cannot be 0. So here we're going to find our domain by saying that x squared plus a 2x minus 24 cannot be 0. Solve for x. So in this problem, in order to solve for x, we would need to factor. So here this breaks into x and x. My last term is negative, so I have one positive, one negative. Factors of 24 that give me a positive 2 are going to be positive 6, negative 4. So in this case, I have that x plus 6 cannot be 0, and x minus 4 cannot be 0. So here x can't be negative 6, and x cannot be 4. So I need to write this as an interval. Again, remember, we're going to go from the smallest most negative to the largest most positive. So we're going to start our domain at negative infinity, and we're going to travel up to the negative 6. That's our first smallest value, and close it. Then we need to pick up where we left off and travel to my next value and close it. And then again pick up from where we were and travel back. So notice my two ends here are on the infinities, and so you always want to make sure that that is happening. And then my numbers are here in the middle. Okay, so the way I like to remember a domain is like this. If I had a list of errands to run, so say for example I have to go to the grocery store, and then I have to pick up my son from school, and then I need to take him to the doctor's appointment. Well, when I drive to the grocery store, I got to park my car and get out of my car. So that would be like driving to the grocery store and I'm parking my car to get out. When I'm done, I have to get back in my car to drive to the next location. So this would be like the Union is where I paid for my groceries and put them back in my car, and then I had to drive to my son's school to pick him up. And so then I would get out of the car to pick up my son, and then I would get back in the car and say drive to his doctor's appointment. So you always want to make sure that wherever you stopped, you are getting back in and keep on going from there. Okay? Alright, let's look at another one. Here we want to find the domain and the range of the following function. So notice I have this function here. Notice a couple of my points are filled in and one of them is not. So when we're talking about points, this would be considered to be an open point. Open points are not included. Whenever we're talking about not included, this means we're talking about parentheses. Now, if we look at These points, so this point here, and this point here, these are all considered to be closed points. This means that they are included, which means we're usually talking about brackets. Okay, so that's kind of how we do it. Now, notice none of these internal points are open. So the only 2 points that we actually care about is the top point here and the bottom point here. And that's just because all of the other points are included in the diagram, which means that we don't have to worry about them. So what we need to do is we need to know what exactly is this point. So we're over at the point -7 and 8. So this is the point -7, 8. And then this point down here, we're over here at the point 5, -7. So we're talking about the point 5, -7. Now normally all coordinate points are made with parentheses, but one of the things that I like to do for myself is I like to put the brackets around just as a way to remind myself that this point is an included or equals to point. So domain x values. We need to start from the smallest, most negative. You are always going to move from left to right. So when we're looking, my non-included point is the furthest to the left. So we have to start there. So my domain here is going to have parenthesis -7, and it's going to travel all the way along until we get here at 5. 5 with a bracket. And that is the domain interval for this graph. Now, my range are the y values. And when we're talking about y values, we are always going to go from the bottom to the top. So from the bottom, we're talking about this most negative side. So here, this would be our lowest point. And we're looking at the y values. So again, here, we're going to start with a bracket at -7. And we are going to travel all the way up to 8 with the parenthesis. And that's all you have to remember when you're talking about domain and range as it relates to a graph. Alright, so the last thing I wanted to look at doesn't really have a lot to do with domain and range. I know it's kind of a funny thing to add on the end of this video. It was mistakenly put in the wrong part of the notes, but that's alright. This here is, we have to determine these two functions. And so here we're given part of it, we need to find the other. So here we have g of x plus a, and so anywhere we have an x, we need to input that x plus a. So this is going to be -4 times x plus a squared, and then we have plus 3 times the x plus a. We need to go ahead and simplify this. So this is going to be -4 times x squared plus 2ax plus a squared plus a 3x plus 3a. Distribute my 4 and we get -4x squared minus 8ax minus 4a squared plus a 3x plus 3a. And now we have to do this actual determination. So we are going to do g of x plus a minus my g of x. So this is going to give us the negative 4x squared minus 8ax minus 4a squared plus my 3x plus my 3a, and I'm going to stick this in parentheses for a minute because we have to subtract away g of x, which was a minus 4x squared plus a 3x. Subtracting away says I need to take this negative and distribute it through my back parentheses. So here I'm going to have the minus 4x squared minus 8ax minus 4a squared plus a 3x plus a 3a plus 4x squared minus a 3x. Notice I have these like terms here, so when I combine them together they should disappear, and same with these. I have these like terms, when I combine them they go away. Notice all of my straight x terms drop out and just leave behind the negative 8ax minus 4a squared plus 3a. So here, the reason why this program is, or this problem is here, is to prep you for doing what's called the difference quotient. And the difference quotient is something that I am going to cover in my next lecture video. So if you have any questions, please let me know. Otherwise, I hope you enjoyed this video on domain and range and a preview to the difference quotient. So sit back, relax, and I'll see you next time.